Today I'll talk about how to name alkanes and haloalkanes. So alkanes, there are three types of alkanes. You have straight chain alkanes like methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, which has 9 carbon atoms, decane has 10 carbon atoms, then you have undecane, dodecane, and tridecane. So the names can continue for a long time, but essentially, so this is a model of methane. This is methane. You have 1, 2, 3, 4. So you have four hydrogens. That's how methane looks like. It's tetrahedral. And this is propane. This is 3 carbon atoms. 1, 2, 3. 3 carbon atoms. Propane. Okay. You can make the models, and I've used the model. You can get any model, but I've used the Maruzen company models. So okay, and then you have this is 1, 2, 3, 4, 5, 6. So you can see most of the times you always draw this zigzag structure for the carbon skeleton, and this is how the zigzag structure is. So that's 6 carbon atoms. 1, 2, 3, 4, 5, 6. This is hexane, 6 carbon atoms, and these are the different hydrogen atoms. It's pretty useful sometimes to make model and see how it looks like. And then for these are the straight chain, and the prefix for these names, as you can see, you have met, et, prop, but, pent. These are all prefixes. The suffix is ane, ane for each of these names. So this is the suffix ane. So ane is the suffix for all of these names. So that's common for all the alkanes. And then we have branched chain alkane. For branched chain alkane, a simple example is right here. This is a branched chain alkane, and you may be kind of familiar with this. This is T-butyl. So the methyl group is the branched here. That's how it is. This is not exactly this molecule, but this is a branched chain alkane. This is the abbreviated bond line structure. And then we have cyclic alkanes. A simple example is cyclohexane. So this is a, let's make the cyclohexane. Okay, so this is cyclohexane, 6-membered ring right here. 1, 2, 3, 4, 5, 6 carbon atoms. Okay, alkanes are composed of carbon and hydrogen. That's it. You can get all different shapes and sizes. So now let's learn how to name alkyl and halogen groups that can be on the parent chain. So parent chain is typically the longest chain, carbon chain. So in this case, let me show you an example. This is hexane. This is hexane, and this is the parent chain. Okay, the 6 carbon atom is the parent chain, and if you can put a substituent here, and let's put a substituent on this, and then you can see how the substituents are on the parent chain. So this is okay. So this is the parent chain, and this is the substituent that's attached to the parent chain. This is the methyl substituent. Okay, so let's learn the names of common alkyl and halogen substituents on the parent chain. So alkyl group is formed by the loss of hydrogen on an alkane, and the ane is replaced by YL. So that's how the naming is. So if you have methane, then loss of hydrogen will give you the methyl, methyl, and so here's the example right here. So this is the methyl, this is the methyl side chain, and then you can have the ethyl right here. There's two carbon atoms, one carbon atom, here are the carbons, so it's two carbon atoms. So this is the ethyl side side chain, and this one is the T-butyl. So T-butyl is the generic name, but as 1,1-dimethyl ethyl is the IUPAC name. So when you're naming the molecule in the IUPAC system, you will be using 1,1-dimethyl ethyl. So how did you get 1,1-dimethyl ethyl? Well, this carbon atom is considered carbon atom 1, and this is considered 2. So there are two carbon atoms, and so it's ethyl. And then these two substituents are considered, these two methyl groups are the substituents, and so they are attached to carbon atom 1. So they are called 1,1-dimethyl, because because there are two methyl groups, and then this is the ethyl. They are located on the ethyl chain. And then let's look at another branched alkyl group. This is 1-methylpropyl. So again, this carbon atom is numbered 1, this is 2, and this is 3, and then a methyl group is attached to carbon atom 1, so it's called 1-methylpropyl. This is the IUPAC name, and this is the generic name. It's called sec-butyl. You'll also see this is a generic name. And then you have another alkyl group right here. This is 2,2-dimethylpropyl. Again, this carbon atom is number 1, number 2, number 3, and so there are two methyl groups attached to carbon atom 2, and so it's 2,2-dimethylpropyl. This is also called neopentyl alkyl group. Then we have the isobutyl group right here. And then you have the propyl group, which has 3 carbon atoms in a straight chain. And then you have the isopropyl group, which is a branched alkyl group. So most of these, you can see these are the branched alkyl groups. So branched alkyl groups, whenever you see the di prefix here, this will be taken into account when we are going to name the final molecule. But if there are several just methyl groups as substituent on a parent chain, the parent chain is the red red solid line right here. That's the parent chain. But if you see several methyl groups attached to the parent chain, say if you have two methyl groups, then you have to use dimethyl. Di is the prefix. So in this case, the di prefix will not be considered during naming the entire molecule. So the prefixes are considered only for branched alkyl substituents. So let's look at how to name when halogen is the substituent. So when a halogen is a substituent, for fluorine you use the prefix fluoro, for chlorine it's chloro, and for iodine it's iodo. So let's look at the IUPAC rules for naming straight and branch chain alkanes and haloalkanes. So first thing you have to do is to locate the longest carbon chain in the molecule with most substituents. This is called the parent chain. Once you have the parent chain, then all groups, that's alkyl group or the halide, attached to the parent chain are considered substituents. And you start numbering the carbon atoms of the parent chain, which is closest, starting from the end, that is closest to the substituent. For example, let's look at this. So the parent chain is 1, 2, 3, 4, 5, 6. This is the longest carbon chain, and so it's considered the parent chain. 1, 2, 3, 4, 5 is not long. Okay, 6 is bigger than greater than 5. So this is the longest chain, and on the longest chain we have the substituent. This is the methyl substituent that's attached. So you can start numbering from from this end of the longest chain, which is closest to the substituent. So if we start numbering from here, 1, 2, 3, so the substituent, methyl substituent, is on carbon 3 of the parent chain. If you start numbering from this end, so you'll basically, this is the correct naming. It will be 3-methyl hexane. You will not start numbering it. You won't number it from this end, because if you start numbering from this end, this is 1, 2, 3, 4, so 4. So this is much farther than numbering from this end. So always number it from the end that's closest to the substituents. Okay, now if there are two or more substituents, then what you need to do is you have to number it in such a way that, let's look at an example right here, and put a substituent right here. And okay, so this again is okay, so this is the longest chain for this one is 1, 2, 3, 4, 5, 6. That's the longest chain. Okay, you can count either way, 1, 2, 3, 4, 5 here, 1, 2, 3, 4, 5, 6. So you can either use this as the longest chain or this. So let's use this as the longest chain because they have the most substituents on it. So in this case, there are two substituents. This is the methyl group substituent, and this is the ethyl group substituent, two carbons right here. So the numbering, if you look at the numbering, if you start from here, you have 1, 2, 3, 4. And you can, so whenever there are two substituents, and this both of the substituents, if you start numbering from here, the first substituent is on carbon 3. If you start numbering from here, it's also on carbon 3. So when you come across an example like this, then you have to go via alphabetical order. So this is called the methyl substituent. This is the ethyl substituent. So you will start numbering it from this side, because ethyl comes first in alphabetical order as compared to methyl. Okay, so that's how you select the which end of the parent chain you have to start numbering. Now, if there are 3 or more substituents present, then you have to pick a numbering order that is that is the lowest number at the first difference, and we'll come across this example. And whenever you have like 2 or more different substituents, then use die and try. Let's look at this same example. So in this case, you have one methyl group right here, and this is another methyl group substituent. So there are two substituents, and this is 1, 2, 3, 4, 5, 6. This is the hexane parent chain, and you have two methyl substituents. So whenever there are two, you use dimethyl. So it will be, that's how it will be. If there are 3, it's called trimethyl. If it's 4, it's called tetramethyl, and so on and so forth. Also remember that you will not use the prefix when you are naming the molecule, and we'll explain more when we get to the examples. For branched alkyl substituents, the prefix is considered during naming of the organic molecule, and the carbon atom that is attached to the branched substituent is numbered as 1. So let's look at an example, so that way you can better understand the concept. So let's look at a simple example right here. Okay, this is the same. This is okay. So this is the same molecule 1, 2, 3, 4, 5, 6, 6, and the substituent is, this is the substituent which is down here. Okay, so that's the substituent, and you can see the carbon atom attached. This is the carbon atom attached to the parent chain, and so this carbon atom is numbered 1, and any substituents attached to it will be also numbered 1. So in this case, this is the side chain is 1 and 2. This is the side chain, so this is the ethyl group, and to the ethyl group on carbon atom 1 is attached the methyl group. Okay, so it will be called 1-methyl ethyl substituent, and that's the IUPAC name. Okay, so the generic name here is 1, 2, 3. So this is isopropyl substituent. And finally, you list all the substituents in alphabetical order preceded with the numbers to indicate the location, and then the name of the longest carbon chain alkane. So let's start with some examples. Let's consider this example. Let's see. So in this particular example, let's see the substituents. There are two substituents. This is a methyl substituent and this is the ethyl substituent. Recall that we need to start numbering from the end so that we reach the substituent as quickly as possible. In this case, if you start numbering from this end, the first substituent is on carbon 3. But if you start numbering from this end, the first substituent will be on, so this will be 1, 2, 3, 4. It will be on carbon 4. So that's the reason you don't number it from this end, but you'll number it from this end. This is the right way. So in all my examples, I have shown the correct numbering so that you remember what is the correct way to do this stuff. To the name, come up with the name. So this is ethyl group is on carbon 3 and methyl group is on the carbon 4. So these are the two substituents. So find the parent chain, list the substituents, and then start writing. So there are 7 carbon atoms in the parent chain, and so it is heptane, and so you'll number it based on alphabetical order. So it's 3-ethyl, 4-methyl heptane. Then let's look at another example. This is, in this particular case, you have halogen is a substituent, and you have a methyl group that's substituent, and another methyl group. Okay, in this particular case, you have 2 methyl substituents and a chloro substituent. So you'll start numbering so that the substituent has the lowest number. So in this case, you have to number this carbon atom as 1 because there's a substituent chlorine on carbon atom 1. If you cannot number this as 1 because there is no substituent on this carbon atom. Okay. So this compound will be called 1-chloro-2,5-dimethyl hexane. So this is the longest chain is 6 carbon atoms, so it's called hexane, and it's called dimethyl. We use the prefix di because there are 2 methyl groups, and they are located in on carbon atoms 2 and 5. Let's look at another example. This looks like a pretty large molecule. So the parent chain has 12 carbon atoms. So it's dodecane. That's the parent chain. That's the alkane parent chain. Now, let's look at the substituent. So you have a methyl substituent on carbon atom 4. So you are going to number it from this side because the first substituent here is on carbon atom 4, but if you number it from this side, it will be pretty far away, I think. And then we have the substituent. So remember that the carbon atom, which is carbon atom that's attached, carbon atom of the substituent that's attached to the parent chain is numbered 1. So this is numbered 1, this carbon atom, and then you have this is carbon atom 2. So these two are considered substituents on the ethyl group. So this is two methyl groups are the substituents, and they're located on carbon atom 1. So this is a branched alkyl substituent. So whenever you, and we'll see how to kind of name it. So it's called 1,1-dimethyl ethyl. The prefix di is used because there are two methyl groups. Okay, and this prefix is considered when we order or name the organic molecule. So we use 5 here because this whole substituent is located on carbon atom 5 of the parent chain, and then we put the name of the entire substituent in IUPAC name. And 4 is methyl group is also located on 4. So let's look at this example. In this particular case, you start numbering from this side because on carbon atom 2 you'll have bromine. You can also number it from this side. It's but remember the rule that if there are two substituents and if both of them are at equal distance from the end of the carbon chain, parent chain, then you go by alphabetical order. So bromine or bromo is higher in alphabetical order as compared to methyl. So we have two substituents, and it's called 2-bromo-7-methyl octane. Octane because there are 8 carbon atoms in the parent chain. Let's consider this example. Here the numbering starts from this end, 1, 2, 3. Why does it do this way? Why not from here? Let's see, 1, 2, 3, and then 4, 5. So in this particular case, you can number from either way, and it's correct. And there are 3 substituents. One is this methyl group, and then this one, and then you have this branched substituent. So whenever the branched carbon atom that's attached to the parent chain is numbered 1, and this is number 2, and so you have a iodo group and a methyl group attached to carbon atom 1. So it's called 1-iodo, 1-methyl ethyl. Remember, this is in alphabetical order. So this is the name of the branched chain that is attached to the parent chain. So the numbering will be, so you put 5 because the branched chain is attached to carbon atom 5 of the parent chain, and then you put the name of the branched chain followed by other substituents. In this case it's 3,7-dimethyl nonane. So there are 9 carbon atoms, so it's called nonane. Okay, let's look at another example right here. So in this case you start numbering it from this end, 1, 2, 3. It's pretty obvious that if you number from this end, the substituent is really far away. So let's list all the substituents. So there are 3 methyl substituents, and then you have the ethyl and also a fluoro. So here you have 1, 2, 3. So these are 3 methyl, 1 ethyl, and 1 fluoro substituent. And so it's named as 5-fluoro, 3-ethyl, 2,2-trimethyl decane because there are 10 carbon atoms are in the parent chain. And the prefix tri is used because there are 3 methyl groups. So remember, everything is listed in alphabetical order. Fluorine, F comes before E, okay, and E comes before M. You do not consider the prefix for unbranched side chains or substituents. So let's look at this example. This has 13 carbon atoms in the parent chain. that's quite a bit. And so this is the ethyl substituent right here. We have two iodo substituents right here, so it will be called diiodo, but the di in this case is not considered while listing the substituents in alphabetical order in the organic molecule. Okay, so we have ethyl, iodo, and 1-methyl propyl. So this is 1-methyl propyl because the carbon atom of the substituent that is attached to the parent chain is numbered 1, and this is 2 and 3, and so on the carbon atom 1 we have the methyl substituent, so it's called 1-methyl propyl. This is propyl, 3 carbon atoms. So this molecule is named as 4-ethyl 6,9-diiodo. So again, it's alphabetical ordering. E comes before I, and then you have the name of the branched alkyl substituent, and which is M right here. So it's methyl propyl, and it's called tridecane because there are 13 carbon atoms in the parent chain. Let's also make sure that we understand the different types of carbon atoms in an organic molecule. So there are different types. So we have primary carbon atoms, we have secondary, we have tertiary, and we have quaternary. So primary carbon atom is attached only to one additional carbon atom. Okay, so anything attached to a primary carbon atom is considered to be also primary. So these hydrogens are primary hydrogens, and this particular carbon is attached to two other carbons, right? This one and this one. So this is called a secondary carbon. So whenever a carbon is attached to two carbons, it's called a secondary carbon, and anything attached to the carbon hydrogens, the hydrogens are called as the secondary hydrogens. This carbon is the tertiary carbon because it's attached to 3 carbons, and so this hydrogen is called a tertiary hydrogen. And then we have the quaternary carbon, which is attached to 4 carbons, 1, 2, 3, 4. So this carbon is called the quaternary carbon. So I've kind of just tabulated that so that in the future videos, when I talk about primary hydrogens or primary carbons, that you understand what I'm talking about, and you will see this used in different reactions in organic chemistry. So let's learn how to name a cyclic alkane or a haloalkane, and these are the IUPAC names, naming rules. So the first thing you have to look at is look at if you can find a ring. So if there is a ring in the molecule, then you count the number of carbon atoms in the ring, and you also count the number of carbon atoms in the chain, and remember that the ring take precedence. So the largest ring is considered to be the parent chain, and if there is a smaller ring, then it's considered as a substituent. Any alkyl or halide attached to the parent chain are considered substituents. This rule is the same as previously regarding the substituents and the numbering and how to number it. The prefixes rules is the same. Branch substituent naming is the same, and this is something new. If there are two substituents on the same side of the ring, then use the prefix cis. If the substituents are on the opposite side, use the prefix trans. So this is specific for rings. And then finally, when you are naming the molecule, you will always list the stereochemistry, whether this is a trans. If you want to learn more about the stereochemistry, please refer to my video on the isomers, which explains with models what a cis and trans looks like and how to further name them. We then list all the substituents in alphabetical order and associated with the numbers to indicate their location, and finally we end with the name of the parent chain cycloalkane. So let's consider this cycloalkane. This is cyclo. So there are two substituents attached to the cyclohexane ring. They are the two bromines, and this is the cyclohexane ring. And so it's the two bromine are on the same side. Probably you know about the convention about the wedged line. So this is on the same side of the ring, and so it's called cis. Okay, so this compound is called cis 1,2-dibromo cyclohexane. 1,2 because the bromine atoms are located on carbon atoms 1 and 2. Let's look at this example. In this particular case, the big ring is considered the parent ring. This is the cyclopentane. So in this particular case, cyclopropane is a substituent. Chlorine is a substituent, and we have the methyl substituent, and the numbering starts always in alphabetical order. Chlorine has higher ranking in alphabetical order, and so it's called 1-chloro, 2-cyclopropyl, 3-methyl cyclopentane. So C and CH and then CY is the, so if the first alphabet is the same as in case of chloro and cyclopropyl, then you look at the second alphabet. So in this case the H has high priority over Y, and so it's written first, and so it also gets higher. You get the lowest number from the chloro substituent. Let's look at this particular example. This is considered as a substituent, and this is the parent ring. So hence it's called 1,2-dimethyl propyl cyclobutane. So this is the parent ring. So let's look at another example. So in this case, this is a 6-membered ring right here, and this OM is the methoxy group, and this is the propyl group. And so it's numbered in alphabetical order again. So cis, it's called cis because both the substituents are on the same side. Okay, so it's called cis 1-methoxy 2-propyl cyclohexane. Thanks for watching. Have a nice day. Like and subscribe.